get into the section on double angle formulas. Double angle formulas just mean 2 times angle A. It's twice the angle. So you can't apply the sum and difference formulas because those involve adding and subtraction. Subtracting, we're now looking at multiplication formulas, which involve 2 times an angle. So the way you develop the 3 double angle formulas is to use the sum formulas. Once you show what they are equal to, you just now create more identities to put in front of you on your big rock sheet and use as you go through the problem. That's all this chapter is introducing identities and then using the identities in trig problems. So we want to use the same identities from yesterday to show what the new identities are today, which are the double angles. When you have the sign of 2a, it's the same thing as the sign of a plus a because a plus a is 2a. I then use the identity, the sum identity, that says that this is equal to the sine a cosine a plus cosine a sine a. The a gets substituted in for the b when you expand that. And at this point, you're going to see that this is sine a cosine a, this is sine a cosine a. They're the same exact term. Since they're the same exact term, you know that this is going to end up being 2 times the sine a cosine a. And this is your next identity. It's the double angle identity for sine. Similarly, we can do this for the cosine of a plus a. When you substitute that in, you're going to get the cosine of a times the cosine a minus the sine a sine a. This becomes cosine squared a minus sine squared a, which is one identity that you can use for the double angle cosine. But there are 2 other ones that you can use as well, and it just depends upon what problem you're working on to determine which identity you want to use. Well, the way that you do this on the other identities is just substitute in for the cosine of a, so cosine squared of a, and the sine squared of a by using your Pythagorean identity, which says that a cosine squared plus a sine squared is equal to 1. And so when you subtract one of those to the other side, you can substitute in for here. So that's what I'm going to do. I'm going to split this down into 2 other ways and then simplify, and then you're going to be forced. You'll be able to use one of the 3. Sometimes when you use one, it's going to save yourself a lot of work. So you want to be selective on what you choose. Therefore, the right side, I can replace the cosine squared with 1 minus sine squared. So that's my substitution for that, which becomes 1 minus 2 sine squared a. Likewise, cosine squared 1a minus, and now I'm going to substitute in 1 minus cosine squared a. Distributing that negative sign, you get minus 1 plus cosine squared a, so that becomes 2 cosine squared a minus 1. These are also equal to the cosine of 2a. And so you have these identities. So far we actually have 4 identities that are new. These 3 come under the same double angle formula for cosine. All right, that's just proving where these identities come from. We also have to do it for one more, which is a tangent, and then you don't have to prove them anymore. We're just going to be using the boxed or the circled identities. So the tangent, same idea, is going to be plugging it into the sum formula, which is tan A plus tangent A all over 1 minus tangent A tangent A. And that can simplify down. So it's going to be 2 of these, 2 tangent A over 1 minus tangent squared A. And that's your other identity, and those are the new identities for this section 5.3. Okay, again, keep those handy, keep them in front of you. Look at those. Don't keep going back in your notebook. You know, you want to keep them right in front of you when you do these problems. So when we look at something like this is number 6 in this section, in the problem set. Cosine x equals 1 over radical 10. You're in the 4th quadrant, and the question is, what's the sine of 2x? So the sine of 2x, what you're going to do is just start with the sine of 2x, expand it, substitute in, and then simplify. So expanding it becomes 2 sine x cosine x from the double angle formula we just got. I now see that I have a cosine x that I can put in, but I don't have a sine x. So I have to determine what that sine x is. How do I do that? I go back to here. I see it's in the 4th quadrant. I know what the cosine x is, so I can draw a triangle and find out the sine x. So I'm going to do that in the 4th quadrant, so I remember that I'm really looking at C there from Santa Claus, and makes sense because the C is positive. 1 radical 10, you want to find what this length is. You could do it by Pythagorean theorem, put an A in there and solve for it. Or you could see that 1 squared plus 3 squared equals radical 10 squared. So you know that that's 3, and therefore you know that the sine of x is equal to negative radical 3 over 10. This right here will be a mistake that students make over and over again on this. Be very careful with that negative. You hate to do all of this work and get the problem wrong because of this negative sign. Plugging that in, you have negative radical 3 over 10, which means that you're going to have no, sorry, I did that wrong. This should be negative 3 over radical 10. Put the radical in the wrong spot. Times negative 3 over radical 10. Okay. This gives me negative 6 over square root of 10 times square root of 10, which is just 10. So that equals a negative 3 over 5. Now, if the question was, what's the cosecant of x, cosecant of 2x, you're going to remember that the cosecant of an angle and the sine of an angle are reciprocals. So that answer would just be negative 5 over 3. So if you want to find the cosecant of 2x, you would find the sine of 2x and then flip it at the end. Same thing is true for secant or cotangent. Tangent theta equals 5/12. You're in quadrant 1. What is the cosine of 2 theta? Cosine of 2 theta. Again, you're going to go to your identities and you're going to fill in one of the identities So you can substitute in and solve. Cosine 2 theta, you could use any one of the three in this case, but I like to just keep it as one trig function instead of two, so I'll just go with the 2 cosine squared theta minus 1 as my identity that I'm going to choose. When you have identities later on, it's going to be more important in terms of which one you choose, because if you choose the wrong one, it's going to take you a lot more steps, and you will have identities to prove using these double angles. All right, so I know I need to find the cosine theta. That's a quick drawing in the first quadrant. I know tangent is 5 over 12. That makes it a 5, 12, 13. Therefore, the cosine of theta is equal to 12 over 13, which means that I go here, 2 times 12 over 13 minus 1, but the 12 over 13 has to be squared. All right, so what is that? It's 2 times 144 over 169 minus 1. Multiplying that through and being able to subtract these, 288 over 169 minus 169 over 169, getting common denominators. And that's going to end up being 119 over 169. All right, let's go to this one. Something a little bit more interesting. We know that if we want to find the sine of 2t, I would expand it, draw it. But let's say instead of this, we want to find out what is the cotangent of 2t. So the whole goal here is if you know the cosecant of t equals radical 5, we're in the second quadrant, and I want to find what is the cotangent of 2t. What I really want to do first is find out what the tangent of 2t is, and then flip it at the end. So my goal here is to remember tangent of 2t. Well, the tangent of 2t has only one identity, and that is that it has 2 tangent t's over 1 minus tangent squared t. Well, this may get a little messy in here, but let's see what we get here. We're in the second quadrant. I want to draw it. Cosecant t equals radical 5. I'm going to remember this is s for sine being positive. Cosine t equals radical 5 means the same thing as sine t equals 1 over radical 5. Which means that my opposite is going to be 1, and my hypotenuse is going to equal radical 5, and this is going to work out real nicely with the numbers, I think. So if I square 1 and I square this number, I have to get radical 5 squared, or 5. So that ends up being a nice 2. Therefore, the tangent of t, because that's what I'm looking for in this, the tangent of t is going to be 1/2, but I have to remember that it's got to be negative. Again, this negative sign is where you want to be very careful. And therefore, I go back to here and substitute in 2 times negative 1/2 over 1 minus negative 1/2 squared. A lot of potential of doing things wrong with that negative. So this is a times, these are minuses. This becomes negative 1 on top. On the bottom, let's see, be very careful here. Negative 1/2 squared is negative 1/2 times negative 1/2. So it's really 1 minus positive 1/4. Order of operations there. Which means that now we're going to have negative 1 over 3/4, which equals negative 1 times 4/3, which is a negative 4/3. I'm not done, because that was the tangent of 2t. I have to remember I really wanted the cotangent of 2t, which means that now it's going to be a negative 3/4. Don't go through all that work and then all of a sudden forget to flip it at the end. Let's take a look at number 22. Number 22 says that I have y equals 2 cosine 2x quantity squared minus 1, and the directions are to graph this. Let's just say it's one cycle. And what you have to do is match that right side up with an identity and then simplify. Now, when you match it up, the matching has to be exact in order to use the identity. If it's not, you can't use it. I'm going to remember the double angle formula for cosine, and one of them says that the cosine of 2x is equal to 2 cosine x squared minus 1. When I look at this, I want to use that. I want to just turn this right side into cosine 2x, but I can't because this right here is different than this right here. Because it's slightly different, I have to adjust for that to make sure that it makes that I can use that identity. So how do you adjust for it? Instead of x here, I really need a 2x on that right side. Well, it's like a function. If you do something to an x on one side, you got to do something to that function of the x on the other side. So if I take an x here and I say instead of that x, I'm going to substitute in a 2x here, I have to do the same thing on the left side to make them equal. So instead of cosine 2x, it's cosine 2, and instead of that x, I'm going to replace it with a 2x, which means that really cosine 4x is equal to 2 cosine squared 2x minus 1, 2x squared. 2 cosine 2x quantity squared minus 1. Which means that this now is cosine 4x. Now, graphing that becomes pretty easy. I have, the only thing that's different is the period. The period is equal to 2 pi over b equals 2 pi over 4 pi over 2. The units are going to equal pi over 2 times 1/4 or pi over 8. When you go to the graph, it becomes adding pi over 8 each time. And looking at these points, it's positive cosine. So I'm looking at that. Using your identity from right to left to transform this more complicated expression into something more manageable. But again, they have to be exact when you match them up, so I had to kind of manipulate that first identity so it matched exactly with the right side of that. We're going to get into more problems like that where you have to manipulate that identity in order to use it. So we're going to spend one more day on this. This is the first half of it. And then the following section is going to be on half angle formulas. Don't forget, if you are going to do a project, to let me know what you're working on, and if you're going to be doing a retake, to sign up for it on Google Classroom.